So this video is going to cover 3 of the 6 exponent rules that you're going to see. The first one we're going to start with is the negative exponent rule. So for the negative exponent rule, what that means is there can never be a negative exponent in your final answer. So if you end up with something that has a negative, say 2, you want to make sure that we only ever have positive exponents. So the way to do that is to move the negative exponent. So for example, in this situation, it's x to the negative a. Technically, if I were to make that a fraction, it would be over 1. So what I want to do is I want to take this part that has the negative exponent and I want to move it. When I move it, that actually makes it positive. So instead of putting it in the numerator, I'm going to put it in the denominator and make it a positive a. And since there's nothing up here, I put a placeholder of a 1. So that's the overall rule for negative exponents. So when I go to number 1, I find what has a negative exponent. In this case, it's just the x to the negative 2. Yes, 5 is negative, but it doesn't have a negative exponent. The only thing we're worrying about is negative exponents. So if I want to set up my fraction, that means that the negative 5 would stay in the same spot in the numerator, but the x, in order to make it x to the positive 2, has to move to the denominator. So x squared would come to the denominator, and that would be my final answer. Now on number 2, you have to use the quotient rule in between before you use the negative exponent rule. So what I would want to do is I would want to say, okay, first I do the coefficients. So I do 4 divided by 8. And 4 divided by 8 is 1/2. So I have a 1 and I have a 2. Then I'm going to look at the k's. So I have k2 and k5. And you might be thinking, well, there's no negative exponent there. Well, when you are dividing exponents, we know that because of the quotient rule, we subtract. So we would do 2 minus 5, which would give us k to the negative 3. Now notice that k to the negative 3 ended up in the numerator. But I know that I can't have negative exponents. That means I have to move the k to the negative 3. Currently, it's in the numerator, which means it needs to end up in the denominator, so that way the 3 becomes positive. But the 1 is going to stay, and the 2 is going to stay because they don't have negative exponents. So my answer would be 1 over 2k to the 3rd. The second rule is the 0 exponent rule. Now, anything to the 0 power, no matter if it's x, 1, 2, 1,000, it doesn't matter. The rule is anything to the 0 power is 1. So I'm going to use that idea to simplify these two expressions over here. So 7. There's no other coefficients to do anything with, so I'll leave the 7. But when I see x to the 0, I know that equals 1. So that turns into 1. I put it in parentheses because it's right next to it. So what I would have to do is I would have to multiply 7 times 1. So 7x to the 0 simplifies to just 7. Number 2 is another one that has multiple rules kind of work together. So number 2 has a power rule in it where it says take w to the 4th and raise it to the 2nd. Remember, the power rule says I multiply these. So that turns to w to the 8th power over w to the 8th power. And now, just like I did up here with my k to the 2nd and k to the 5th, I'm dividing w8 divided by w to the 8th. So I would do 8 minus 8, which gives me w to the 0. But as we just learned, anything to the 0 power is just 1. So my final answer there would be 1. Now I said we were going to do 3 of them. The other rule that we're going to do is we're going to switch from radical form and rational exponent form. So radical form, okay, this is a radical. So this one is radical form, and this would be rational exponent form. So sometimes you're going to get questions that look like the radical form, and you have to figure out the rational exponent form. Other times you'll get the rational exponent form, and you have to figure out the radical form. So I'm going to teach you a way to hopefully remember and distinguish between the two. So for example, if I were to start with a problem that looks like this, we call this number in here, we call it a root. And this number, you should know, a power, we call an exponent. And if you think about exponents, exponents are at the top. Now, here's how I think about this. Root. If I think of a root in general, I think about a tree. So if I have a tree, look at my nice drawing, I have roots that are underneath the ground. Okay, these are the roots down here. So when I go to my fraction, my root has to be my root underneath, right? Underneath the ground. So my 3 is going to come here. And my exponent, right, is the top. It's like the tree top, okay? So this top of this tree, right? It's like the tree top, which means the exponent's going to be on top of the ground. So my 4 would come here. Now, if I wanted to go the other way, and it might help you if you want to go like this. So it goes up there, and then the root comes down. You could draw those for yourself. Now, on the other way, if I start from the rational exponent form and say this is a 3 and this is a 2, here is my ground, here's my root, right? It's in the bottom. So my root goes where my root goes, which would be a 2 here. And my 3 is at the top, like the tree top, so it's going to be a top, it's going to be an exponent, it's going to go here.